Alright, and we're back for part 2 of chemical reactions. So in part 2 we're going to talk about single replacement and double replacement reactions. So we talked a bit about these two types of reactions in class, and we've actually seen them happen. So hopefully you've had some good experience with these and you're starting to get the hang of them. So in single replacement reactions, on the reactant side, or the left side of the arrow, we have a compound and we have a single element. And on the reactant side, we're going to have a compound and a single element as well. But in this case, it's kind of like the couple goes to the party. So this is our couple, our compound, barium nitride, goes to the party, and they're a couple and they're happy, but oh, they find magnesium. And magnesium is, you know, pretty cool. Magnesium's got it going on, got a little bit of swag, as the kids say these days. And magnesium is going to steal nitrogen from barium. Okay? So magnesium is going to steal nitrogen, so that gives us a compound that contains magnesium and nitrogen. So remember, every time we create a new compound, we have to do the drop and swap, or the crossover rule. So we've got magnesium 2+, that's going to drop down and give us 2 there, and then the 3 is going to come down and it's going to drop down there. So we have magnesium nitride looking like that. Okay. And then what happens when magnesium steals nitrogen from barium? Poor barium is left all by itself over there. So, and as you can see on the product side, we also have a compound and we have a single element. They've just kind of done a little bit of a switch. So note, and it's important to note, that magnesium is a metal, and then we've got our metal and our non-metal in the compound. So magnesium is a metal, so it's only interested in stealing the non-metal. If magnesium were a non-metal, it would steal the metal, and so I'll show you what one of those would look like. So in this case, let's say we've got lithium sulfide and chlorine. Alright, so in this case we've got our metal, we've got a non-metal, and chlorine is a non-metal as well. So it's the same deal. The couple goes to the party, they're having a good time, oh, but chlorine's there, and chlorine has got its eye on lithium. So lithium is going to form a compound with chlorine, and same deal, we go lithium is 1+, Cl is 1-, we do the drop and swap, that's a 1, drop and swap 1. We don't write ones, okay, because it's just repetitive. So that is our final compound there. And then in this case, it's poor sulfur that's left all by itself. Okay? So yeah, that's pretty much a single replacement reaction. Now this first one up here we've left unbalanced, so we've started to do a bit of balancing. Hopefully we're getting the hang of it. But let's just walk through this one. So I've got 3 magnesiums on the right-hand side, which means I need 3 magnesiums on the left-hand side. So I add a 3 as a coefficient there. I've got 2 nitrogens on the right-hand side, and good news, I've got 2 nitrogens on the left-hand side. I've got 3 bariums here, so that means I need to add a coefficient of 3 out there. So that's just a little quick note on balancing. So those are the single replacement reactions. So we've got a compound and a single element. The single element steals one of the members of the compound, forms a new compound, leaving the other element in the original compound by itself. And so it does depend whether you've got a metal or a non-metal as that single element as to what the new compound is going to be. So keep in mind that as you're going forward. Alright, so double replacement is sort of similar to single replacement, but in our double replacement reaction we have 2 compounds. So we've got a compound reacting with another compound. Okay? And this is the old partner swap. So this is the one where 2 couples go to the party and they see another couple, and the other partners of that couple seem more interesting than the person they came with, so we get new compounds forming. So the metal from compound 1 is going to steal the non-metal from compound 2. So in this case, it's lithium and it's sulfur we do our new drop and swap, S2 minus, the S drops down there, 1 drops down there, we don't write our 1s, so it's Li2S. And then the metal from compound 2 is going to steal the non-metal from compound 1. So notice the non-metal from compound 1 is one of our polyatomic ions. So we've got beryllium, and that one is called sulfate, so SO4. So beryllium is a metal that has an ion charge of 2+, and we've got SO4 with an ion charge of 2-. So the 2 would drop down there, this 2 would drop down there, but just like in math, we're going to reduce those down, so it's just BeSO4, so that's our final compound there. Okay, so that's all there is to it. It's the old partner swap. But now we've got to balance these out, so let's just check that out real quick. Lithium, I've got 2 lithiums on the left, I've got 2 lithiums on the right, so let's just plunk a 1 in there. We usually don't write 1s, but it's good to know that, well, we've already balanced those, so we know not to touch those again. Okay, that gives us 1 sulfate, and remember, you want to really take those polyatomic ions and balance them as a block. You don't want to take the sulfur and the oxygen out individually and balance them, you want to balance them as a block. So I've got my 1 sulfate over there, I've got 1 there, so that tells me that they're balanced. So I'm just going to stick a 1 in there. I've got 1 beryllium on the left, I've got 1 beryllium on the right, that's good, and I've got 1 sulfur here, and I've got 1 sulfur there. So this one's actually already balanced for us as well. Alright, so that is your double replacement reaction. So 2 compounds, they switch partners. So the metal from compound 1 takes the non-metal from compound 2, and then the non-metal from compound 1 is going to make a compound with the metal from compound 2. Alright, so that is it for part 2 of chemical reactions. The next set's going to have neutralization and combustion. So hopefully we're getting this stuff. Alright, thanks guys.